So, welcome back. In this video we will investigate how we can extract API documentation, function documentation, module documentation and similar from Python source code using the Sphinx documentation system. In order to follow this exercise, you will have to install some components which you might not have yet in Conda. So please make sure that you are installing the Sphinx documentation system, the Sphinx book theme, which we will use because it's a nice theme to make documentation, and the make tool, especially if you are using Linux and this is not installed for some reason yet. Maybe a few words about API documentation and API itself. So basically API is nothing else, just the programmer interface, the application programming interface of your program. So think about that, all the public modules and routines which you are exporting to the world, to other modules, that's the API, and they should be of course documented. Why is it important to document? Because of course people who are using those routines should know what is the purpose of a given routine and what are the input arguments and what this routine will return. Python offers a very nice way to do that. So basically we can do it in the Python Docstrings, which we already used before. So it's not very complicated. The question is how we can extract this documentation out of those source code, and it's very important to extract it actually, because of course people who want to use your routines, like you are using for example NumPy routines, do not want to have to deal with the source code itself. It would be nice if the documentation of our project can be, for example, represented as HTML pages. And this is exactly what we are doing here in this section, and we will extract the API documentation using the Sphinx documentation system. The Sphinx is a very nice documentation system. It can be used for many purposes like user manuals, reference manual, etc. I would say that it's good for a middle to large document, and we will use it to extract this API documentation from our project. And basically the Sphinx is the standard tool in the Python world. So basically most Python projects are using Sphinx as its documentation system, and Sphinx can read so-called restructured text documents, and reads comments in restructured text format. This restructured text format, maybe in a very nutshell, just very shortly, it's a text format which enables HTML or text-like formatting, but it uses a sort of a kind of picturesque notation. For example, if you want to create a chapter, you would just add the stars above and below the chapter, the so-called decorators, which are exactly as long as the chapter title, and then this is basically declared automatically as a chapter. If you have a section, for example, then you could use this notation in order to indicate a section or a subsection, and so on and so on. If you want to emphasize something, make in italic, then you just put a star, and if the emphasized text is over, then just one more star. Or if you have double star, then it would be bold. Or for example, you can also use mathematical formulas, mathematical expression, and using LaTeX to render them. This is quite cool and quite fancy feature. You would just write that math prefix, and then between back quotes you would just write the equation in LaTeX, and it would be rendered correctly. And then you can also have bulleted lists like here, or enumerated lists, which you can use exact numbers, or you could also use hash mark and dot if you do not want to write the numbers themselves. The one thing with the restructured text you should be aware of, that's similar to Python, is indentation dependent, and that's super important. So basically here in this kind of block where we are creating the talk tree, the table of content tree, then to these directives there are some options which belong to, and they must be indented correctly, and the options which I'm specifying must be exactly indented exactly the same way as, for example, this thing here, which tells me that okay, into the talk tree you should also include the API, the file api.rst. Or if you are basically creating something like a code example, then we would use double colon, and basically here the example itself, which should be typeset as a code, should be again indented correctly. 2 spaces or 4 spaces doesn't matter, but it should be consistent. So restructured text is super useful and very powerful, and I'm definitely not showing all the details which you can achieve, or all the features which you can achieve with RST. Please look at the documentation. There is a nice quick restructured text introduction, or there are also other documents. You can look it up, any kind of introduction which shows you the power of restructured text. What we will do now is basically just to take a project or linear solver project and just create documentation, and instead of on the slides I will just show it live, because that's maybe a little bit more intuitive. So basically what we need, or more project is the lin solver project. We typically put the documentation into a folder docs. So basically if you have a docs folder, then you should create it, or if you do not have a docs folder yet, you should create it. I have it already, but I will just delete it so that we can start with a fresh folder. So I don't have a docs folder yet. I'm just creating docs as a folder. I'm just changing into the docs folder, and then I'm just using there's nothing inside, and I'm choosing Sphinx quick start in order to start a new documentation project. So Sphinx quick start starts ask a few questions, and for most of them you can just use the default option. The project name, I will call it lin solver, and I am the author of the project, and for everything else I will just take the default value. And if you have a look at that, it creates basically a folder with certain directories, like here's the build directory, here's a static template library, a configuration file called conf.p, and it contains already an RST file, index.rst. And before we start, we will just edit this configuration file with a few options which we will use later. And this option I will just edit in Visual Studio Code. So we are editing conf.p in the docs folder, and first of all I will use a few extensions which I find very useful in our case. And the first extension we are using is the Autodoc extension. This will make sure that we can automatically get documentation out of Python files. I will use the so-called Napoleon extension, which is there so that we can extract our documentation from a format. We can write our documentation in a format which we used during this course already, which I have shown already, the Google style Docstring. And in order to be able to render mathematics in the HTML pages nicely, we will use the Matjax extension. So those are the three extensions. I will also change the HTML theme to something modern and quite nice, and I like the Sphinx book theme a lot, so we will use that one. And finally, here at the very beginning, because we will have to extract documentation from something which is in another folder than the documentation. The documentation is in docs folder. However, our main program, which contains the documentation solvers.py, is one directory higher, and we must make sure that the documentation system can import this module. But this module is not in the same folder as the documentation, and therefore we have to tell the documentation system or enable the documentation to find it. And we can just do that here in this Python configuration file by importing the path and from the pathlib module, and importing the sys module. And there is a sys.path variable which contains basically all the directories where Python should look for a certain module when importing, and we are just inserting at the 0th position, so as the very first position, the parent directory of this configuration file. So we are calling path and cvd. This is a current working directory. It gives us the current working directory, but this is not what we need. We need a directory one higher up, we are calling it, this is dot parent, and this is dot path, expect a string, so we are converting this POSIX, this path to a path object to a string. So with that, we can make sure that our module can be imported. Now let's have a look how is our index.rst file looking at. So we are opening the index.rst file here in the same directory, and basically something was already created. As you see here, already some title was created, and so on and so on. I will change that just simply to the name of the project LinSolver, and I will use a different kind of header. Basically the header markers are arbitrary as long as they are consistent. I will use just LinSolver. We have here a Docstring, so the table of content, the max depth, I will leave as it is, and I would here make sure that I'm also including a document called APIs when we will have to create a new file API. Okay, and this should contain the automatically extracted documentation. So let's create here a new file. I would just save it under the name api.rst, and again here I'm just making a header. Let's call it LinSolver API. So this is basically the API documentation of the LinSolver project, and instead of writing it by hand, what is there, it should be extracted. So let's have a look at the solvers module itself, which contains, for example, the solve routine, and we are using here, as you can see, the Google style documentation specifying the arguments, the return values, and what it raises. And I'm also using some mathematical symbols in order to demonstrate. And now it would be good if the documentation system would import this solvers module, take all the subroutines, all the functions in this solvers module which are there, and it would extract the documentation out of that. And this is something we can very easily specify. We are just here specifying the directive auto module, which would automatically import the module named solvers, and then we have to tell them what to render, and then basically we will just render all members, and that's it. It should in theory now go import the solvers module and render the documentation of all members. Now how can I execute that? If I'm here in the docs folder, I can just say just make HTML. So basically generate the HTML documentation. The problem is one has to be in the docs folder, and then I'm just saying make HTML and Sphinx here run, but I found an error in the API. It says it api.rst in the 5th line, invalid value member, because it is called members and not member. So let's try to correct that and run it again, and now there were no error messages. So it generated some documentation in the build.html folder, and so let's have a look at that. I will just have a look with Firefox on the build.html index.html file, and if I start that, then I have a very nice document here, LinSolver. It calls, at the moment it doesn't contain much, just the LinSolver API, and it also shows the functions because the Docstring depth was set to 2. That's maybe not that nice, so I will just go back and I will set here the maximal depth to 1, so that only the chapter names are appearing. I'm just here generating it again, and then sorry, I'm just reloading it here, then it vanishes. And if I here click on the LinSolver API, then we have a very nice representation of the documentation. Here's, for example, the backward substitute routine accordingly, and then here are the arguments, and then here is the description. This is the equation which I was entering, it was really rendered in LaTeX. And then there's a list of parameters with the description of the parameters and the return value. So it's actually quite nice. And this is basically it. Of course, we should add those things to our Git repository, and it's always a big question what to add to the Git repository. And we definitely should not add the build folder because it's generated automatically. Actually, we should add that into the git ignore file. So let's first say git add. We will add the mate file, the static folder, which Sphinx generated, the templates folder, which we can put some template inside, the api.rst, which we created, the configuration file, the index.rst, and this make.bat. This is what has to be executed on Windows if you want to generate the documentation. And then if you have a look at that, that looks quite good. The only thing which we didn't add is the build folder, and the reason why you don't see it by git status is very simple, because I already added that to the git ignore file. So basically here, if you are loading the git ignore file, you see that I have add docs/build, and that's it. And then I can basically here just check it in, just commit it. So I can say git commit, and then just that guys can make some commit message like extract API documentation via Sphinx. And with that, you are able not just to write documentation, but also extract your documentation from your Python projects.